This lesson is going to work you through stoichiometry problems where you are converting moles of a certain substance and predicting how many moles of another substance you're going to either need or get. So we call these mole-to-mole stoichiometry problems because you're given moles of a certain substance A, let's say that is your given, and you're asked to find the mole of something else, which we call substance B. This is your unknown. So let's take a look at this problem and identify why it's a mole-to-mole problem. So your given already tells you have 5 moles of propane. We know that that's substance A. And then moles of B, how many moles of carbon dioxide is produced. So you see again it's moles that they're looking for, and this carbon dioxide is your substance B. So this clearly is a mole-to-mole stoichiometry problem. So the first step that you need to do in any stoichiometry problem is to write the equation and balance it. And in this case, we have propane. I know that propane is C3H8, and it reacts with oxygen. And I know that because anything that's burned needs to react with oxygen. This is a combustion reaction, just like we've been working through in class. And as a result, you have carbon dioxide and water. So the next step is balancing. You'll notice these are not balanced. I have 3 carbons here. I need to get 3 carbons here. Hydrogens, I have 8 here. I need to get 8 here, so I place a 4 there, and that should work out to be a total of 10 oxygens. So now I have a balanced equation. And what this balanced equation says is that for 1 mole of propane, you are required to have 5 moles of oxygen. And when those combine, they produce 3 moles of carbon dioxide and 4 moles of water. In other words, that for every 1 mole of propane, 3 times the amount of carbon dioxide is made. So it's a proportion. This is a 1-to-3 ratio, and I know that based on my balanced equation. So that is going to be key to what we're going to be doing. So the next step is to use this equation to find your ratio. So the next step is find ratio. And as I said, I know the ratio, and this is through the chemical equation. So my chemical equation says that for every 1 mole of propane that is burned, I produce 3 times the amount of moles of carbon dioxide. See how there's a 1 invisible 1 here and a 3 there. And I'm going to make these into what I call ratio tiles. I simply place them into a fraction. So 1 mole of C3H8 over 3 mole of CO2. Because of these being equal, and I'll make that into an equal sign, I can place those into a fraction. I can also write it another way. I can write it 3 moles of CO2 over 1 mole of C3H8. So these are both the same thing. It's just different ways of writing it, and we're going to now write them different ways so that we can select which of these tiles we're going to best use for our problem. So the last step is doing the actual solving. So I know that I am given 5 moles of propane, C3H8. And keep in mind there's that invisible 1 below that. And I can convert that using dimensional analysis. I need to make certain what I have up here as my numerator is going to be identical to what I have down here. In this case, I have moles C3H8. So that means I need to have moles of C3H8 on the bottom so they cancel out. So you're going to look at this tile. Does this tile have moles of C3H8? No, it doesn't. Does this one? Yes, it does. This is the tile I would like to use. So that means I place 3 moles CO2 on top, 1 mole of C3H8. So why am I doing that? It's so that I can cancel these out. That's why it's so important to label. Remember, what you have on top can be canceled out by what's on the bottom. I no longer have propane or moles in there. I simply have 5 times 3 moles of carbon dioxide, and my answer should then be 15 moles of CO2. Okay, does that seem reasonable? And if you're like, well, if I know the ratio is 1 to 3, if I have 5 moles of propane, then I should have 3 times that amount, which is 15. So that answer seems reasonable. Sometimes the numbers, though, are not quite as easy. So here's an example that's identical to what we've just done, but now the mole number is maybe a little bit different. So I have our balanced chemical equation. I'm going to work on step number 2 because I've already completed writing and balancing the equation. Remember, I'm identifying what my ratio is. Mole A is my given. Mole B is my unknown. Okay, so in that case, mole A is propane. So I'll just write propane. And keep in mind, this is what you get from the equation, this ratio. So we're creating the tiles. So I know from my equation that 1 mole of propane, that is my given, and B, remember, is the one that I don't know. In this case, it's going to have to be carbon dioxide. Based on this, I know that it is a 1 to 3 ratio, meaning 1 mole of propane to 3 moles of CO2. So now I create those tiles. So I've created those tiles, in which case I simply place them over each other. Because I know that these are equivalent, I can make those into an equal sign again. And now I need to determine which one of these tiles I want to use. Well, if I have moles of C3H8 on the top here, that means I need to have moles of C3H8 on the bottom here. So 1 mole of C3H8 to 3 moles of CO2. It's all about canceling out. So my moles cancel out, my C3H8 cancels out, so that I'm simply left with 2.8 times 3 to be 8.4 moles of CO2. So let's try a different problem that might be a little bit looking at it from a different way. So in this case, I now have how many moles of propane did you burn if you have 2.5 moles of carbon, if 2.5 moles of carbon dioxide were produced. Remember, this here is my given. This is my A. Propane is my B. I notice that this is a mole-to-mole stoichiometry problem. So the first thing I need to do is set up my tiles. So I know that mole A is carbon dioxide. So when I look at this, it looks like, thanks to the equation, 3 moles of CO2, right here is those 3 moles, require 1 mole of propane to be burned. So this is my mole B at this time. Remember, B is your unknown. So I simply look at the equation. I see that it's 3 moles of carbon dioxide to 1 mole of propane. Remember, this is your given, and this is your unknown. So the next step is I'm going to make my tiles. So you notice my tiles are absolutely exactly the same as the previous problems because it is the same proportion. And in this case, again, I write them either way. The only difference is that when I solve this, remember that I always need to make certain that what I have in the numerator up here has to be in the denominator there so that they cancel out. So in this case, I look for moles of carbon dioxide at the bottom, and I notice this is the tile that I want to use, where carbon dioxide is on the bottom. And my apologies, it should be a 3. So that means that we have 3 moles of CO2 for 1 mole of C3H8. And if I do that calculation, this time I'm not multiplying, I'm actually dividing, so that I have a number of 0.783 moles of C3H8. And let me go ahead and cancel those values out so that it makes it clear. Let's look at one more problem, and that hopefully will give you enough to work through some mole-to-mole problems. I'm going to set this one up and just kind of talk you through it once it's set up. For this equation, we have how many moles of propane did you burn if 0.56 moles of water were produced. So again, we have our balanced equation, and the first step is that you want to get this mole ratio. So my known in this case is water. That's the value that has a number, and my unknown is the propane. So I start with the ratio based on the equation, and here I look and I say, okay, looks like there's 4 moles of water produced for every 1 mole of propane that's burned. I place those into tiles showing either direction, one time with water being on top, one time with water being on the bottom. The next step is I take the known value that I have, which is from up here, 0.56 moles of water, and I multiply it so that I can cancel with a tile that allows me to cancel out those moles of water. So I need to make sure, knowing that moles of water are on the top here, that moles of water are on the bottom here. They cancel out to get this answer.